Okay, so practice exam number 2. Number 4. Question number 4. How do we do sine of tangent inverse of x? Sine of, well, it's already written out there. Sine tangent. So when you see that, what do you think about that one? What do you do? Sine and tangent when they... A lot of the battle is recognition. So notice that they're mixing forms. They're mixing sine and tangent. When they do that, that's when you got to draw the triangles on the unit circle and do that whole thing. Not making sense? That's the game plan. So let's do that. So I'm going to draw a triangle on the, put my angle theta right there. Always put that at the origin. We good there? Right angle here. And how are you going to recognize that on the exam in about an hour or hour and a half? Hour and a half is you will say, oh, when they mix them, like if that was tangent inverse, it was the same function twice, that's when they cancel each other out. Right. Maybe, if they're in the zone, right? But if they mix different functions, like sine with tangent inverse, that's when you got to draw triangles on the unit circle, right? Okay. So now, take that inside piece, and it says tangent inverse of x. Now remember what the story is with inverse trig functions. If you have a normal trig function like tangent, you put in an angle, you get out an answer. But with inverse tangent, or inverse sine, or inverse cosine, what you plug in is an answer. What you get out is an angle. They swap positions, don't they? The inputs and the outputs. That's what's inverted in an inverse function. They invert, they switch inputs and outputs. Okay, so why am I talking about all that? Well, that means that this x is the answer, actually, huh? And what it equals is the angle theta. Right? That makes sense because it's an inverse trig function. So that means what's being plugged in is an answer. That's what I'm writing there, A-N-S. Answer. And what comes out is an angle. Okay. So that means tangent, regular tangent. It's not, see how I just changed to regular tangent, not inverse? Regular tangent of theta equals x. That's what that means. Is that confusing? Is that okay? Everybody make it. That'd be like, let me see if I could write it with real things in it. That'd be like me saying tangent inverse of 1 equals 45 degrees, or tangent of 45 degrees is 1. Do you see? Tangent inverse, you put the answer, equals the angle. Regular tangent for the angle equals the answer. That's what I'm saying here. You want to be really, really clear on the difference between normal tangent and tangent inverse, or normal sine and sine inverse. You swap inputs and outputs, right? Everybody with me on that? Normal tangent inverse, you put in the answer, get out the angle. Regular tangent, you put in the angle, get out the answer. So I'm changing from inverse tangent to regular tangent, so I put in the angle, get out the answer, right? Okay. So with that in our mind, let's put that information on the triangle, and we always use SOHCAHTOA, don't we? Always use SOHCAHTOA. So SOHCAHTOA. What does it say? Tangent of theta is x, and tangent is TOA, so that means it's opposite over adjacent. So I need to look at that x like a fraction, don't I? I need two numbers. I need an opposite and an adjacent. How do you look at x like a fraction?
Put it over 1.
Put it over 1. So here's the angle. This is opposite side, adjacent side, hypotenuse side. So it says opposite. The opposite here is x. The adjacent is 1. Good so far? See how I'm putting that on the triangle? Tangent is opposite over adjacent, x over 1. And now, how do I find the hypotenuse? Pythagorean. Getting the hang of these? whenever we draw these triangles, we always use SOHCAHTOA and the Pythagorean theorem. Every time. Whenever we have a mix of trig functions, sine and tangent inverse mixed, they're not the same. They're not sine twice or tangent twice. They're a mix. Whenever you have a mix, you draw your triangles. Whenever you draw your triangles, you use SOHCAHTOA. See how I'm using TOA here to put that on the triangle? Use SOHCAHTOA and the Pythagorean theorem. So here we go. A squared plus b squared is c squared. That's 1 squared plus x squared is c squared. So that's 1 plus x squared is c squared. How do I find regular c? Root it. Root, boom. Regular c is the square root of 1 plus x squared. Now it looks like I could square root each of those, huh? Square root of 1 is just 1, square root of x squared is just x. But you can't. It's actually not allowed. Why not?
Because of the glue in the middle.
Because Mr. Heron says no. No, that's not a good reason. It's because of the glue in the middle. Because pluses and minuses wreck algebra. They really do. They are what make algebra hard. If you just have that in the back of your mind, it'll make it easier as you do if you go higher in math and do other pre-calc and stuff. Pluses and minuses are all the hard stuff. If that was times, if that was the square root of 1 times x squared, I would totally just square root of 1 and be 1. Square root of x squared just be x. It'd all be good if it was times. But pluses and minuses glue everything together, make you not be able to do anything nice when they're involved. Okay, so it has to stay just like that. All right, so what? Well, let me put that on the diagram now. That's c. That goes here, doesn't it? 1 plus x squared. Everybody good there? That's the hypotenuse. That's the c, ABC. C is always the hypotenuse. Okay, so what? Well, now I'm ready to wrap up the question. Because from the beginning it said sine. I haven't brought that part in yet. Sine of what? Sine of, and I don't know if these, when I make brackets, it doesn't, that's the same as a parenthesis. It's just a different style. It doesn't matter. It's all the same thing. Of tangent inverse. What's tangent inverse? Whoops. Tangent inverse right here is theta. Theta. So what they really want is sine of theta. Did everybody see what I just did there? That inside tangent inverse right here. Tangent inverse equals theta. So that whole inside tangent inverse, that's just theta. This is just sine of theta. Everybody say, why? Why? Because remember, this is tangent inverse, which means that x right next to it is an answer. Right? You always want to remember, inverse trig functions are reversed. So you plug in the answer. Well, what comes out of it is the angle. Huh? So that tangent inverse spits out a theta, an angle. So I need sine of theta. In the end, I need sine. What's sine? Opposite over hypotenuse. Opposite over hypotenuse. X over the square root of 1 plus x squared. There's my answer, except I can't leave roots on the bottom. So let's bring it over here. One more step. How do you get rid of that root from the bottom? Multiply top and bottom by root of 1 plus x squared. And I get x root of 1 plus x squared over plane 1 plus x squared. Is that answer there? Yeah. A. It doesn't matter that I had the other order, right? 1 plus x squared plus 1, same thing. It's answer A. Is everybody okay with that? You okay with what happened on the bottom? Remember when you have two of the same roots? It's one of those regular. Remember that from algebra? Like, remember from algebra, root 7 is plane 7, root 11, plane 11. Remember that? I tell my algebra students they're a 2-for-1 deal. Like at Target. If you're shopping at Target and things are on sale, 2-for-1. 2 7s in the root, 1 7 out. 2 11s in the root, 1 11 out. That's what roots always do. That's why they're called square roots. Square means 2, huh? Whenever you say square root, you're saying 2. Right? Square root. Cube is the word for 3. And square is the word for 2. When we call that a square root, we mean it's a 2-for-1 deal. That's what they are. So root 1 plus x squared, root 1 plus x, 2 of these in a root means 1 out of the root, doesn't it? 2 in target, you pay for 1 going out of target in a 2-for-1 deal. All right. That was just one problem. That was a long one, though. On to number 5 we go. Let's talk about it. Okay, so yeah, remember how we learned about period? We said this is A, this is B, the 3, and this is C. So period What's the period formula?
2 pi over.
2 pi over b. So 2 pi over, what's b? 3. 2 pi over 3. That's a little quicker. That's all you got to do. Period is just 2 pi over b. B is whatever number is multiplied right next to x. C is the other number added or subtracted in the parentheses after the x. And D, if there was something out here, it's 0 in this case. It would be the number added outside the parentheses. A, B, C, and D.
There's no formula for D, right? D is just a shift.
Yeah, D is just a vertical shift.
Doesn't.
Just moves the middle up or down. Yeah.
But there's no formula to calculate it. Just
Right.
adding.
That's right. All right, so then number 6 says determine the phase shift. The phase shift. Okay. Again, this is A. B is -2. C is pi over 3. So phase shift, if you have that formula written, it's negative C over B. Phase shift is negative C over B. So it's going to be negative. And what's C? Pi over 3 over B, which is -2. You all good to there? So negative in the front, pi over 3 over -2. Good? And now, how do we deal with like a fraction over a fraction? Or a fraction over a whole number?
Multiply over its inverse.
Yeah. Dividing is upside down multiplying. So I take that, this is the big bar here, take that -2 over 1, grab it and flip it up. It's times 1 over -2. You with me? Don't forget about this minus in the front. Minus pi over 3 times 1 over -2. Everybody good so far? Two negatives are positive. Pi over 6. Positive pi over 6. Positive pi over 6.
So does a negative, is it with a pi or in front of the whole fraction? Does it make both of them negative?
It makes
Like
the
pi
whole-
3, is it negative pi or -3?
Oh, good question. Good question, Jose. Yeah, let's talk about negatives in general. If you have a negative on a fraction, I'll just do a half, could be any fraction. That negative goes on the top only, or the bottom only, but never both. Why not? Why wouldn't we put it on both? What is two negatives? Positive. See, that would change it back to positive, huh? So it can't go on both. It's on one or the other. It doesn't matter which one. Or the front. Front, top, bottom, it's all the same thing. Doesn't matter wherever you want to do it, but don't do both because that'd actually be positive. Good question.
So when you flip the other number, what if it also has a negative on either top or bottom? It would change it.
All right, and this one did. This one had a negative on the top. So I grabbed it and flipped it up. The negative was there. And then this guy had a negative. So really, in the end, Jose, don't worry about negatives and where they go. It's just how many you have. So I would just look at this problem and go, look, we got two negatives. Wherever you want to put them, we got two negatives positive. And I think it'd be easier than worrying about traveling with it. Yeah, because it doesn't really matter where they're at. If they're all multiplied together anyway, it's just two negatives, anywhere, positive. Yeah, good question. Everybody seeing that? His question's a good one. So that negative in the front, with the negative down there. Yeah, probably the best thing is right away just grab those two negatives, put them together, positive. And then just grab the two and flip it. Yeah. Positive. Anyway, so it's positive pi over 6. So that's pi over 6 units to the right, isn't it? Wasn't that the answer?
Yeah.
B. To the right. Positive. Good. All right, we'll keep moving. All right. So look at number 7. So minus 3 sine 2 pi x plus 2 pi. Okay. So this is A. The 2 pi is B. And that last 2 pi is C. A, B, C, yeah.
I have a question.
David.
About the phase, like the shifting.
Yeah.
So if there's no like 2 pi, it's just like x, and it's just like -2. Does it go to the right then, or does it go to the left?
So what's your specific question again?
So like in the parentheses, there's like x, and that's how it's like the phase shift, how much it shifts over.
Right.
I thought it was like if it's negative, like it's gonna go to the right, and the opposite if it's minus, or is it to the left?
Yeah, so you're right. From parentheses to graph, it's opposite.
Okay.
So notice if you're just like looking at these parentheses and you're seeing a plus there, oh yeah, no, it's not that simple because that guy threw it off. Yeah, no, don't do it that way. Yeah, I was trying to go with an easier rule too. No, in general, that's what just do my little formula, which is negative c over b. Now, I don't know do you spend a lot of time looking at the show me an example button?
Yeah.
Because if you do that, they put a positive here. Remember, I warned about that. I said they use a different formula than me. Theirs is fine, but I don't want you to get confused between the two. I found it's easier for students to do it this way. So I say they said the phase shift is regular C over B, and then they said opposite. I found that confused the students.
Okay.
So I just say, look, it's just negative C over B, and then it's just regular.
Flipping it right there.
Yeah, I'm flipping it right there.
Okay.
Exactly, David. You're tracking it. Yeah.
And then whatever is positive negative is to the left.
Yeah, positive right, negative left. Yeah, so I just put this minus right in the formula. That handles the opposite thing. Exactly right. Yeah. All right, good. So, all right, so ABC. So we got to start with the, the amplitude, -3. No big deal on that. Amplitude, -3. Let's go on to the period. 2 pi over B. So 2 pi over, what's B? It's 2 pi, so that's just 1. And then let's do the phase shift. The phase shift, negative C over B. Negative C over B. What's C? It's 2 pi. Right there. Over B, which is also 2 pi. It's -1. So that'll be back 1. Yeah, you just take it straight. So that'll be back 1. So the phase shift is -1. Okay. So, and now it's time to draw the graph. So let me bring those over. Because that's the easier part, huh? The hard part is getting a look at this thing. So what was it? -3. -3 sine 2 pi x plus 2 pi. Did I get that right? 2 pi x plus 2 pi, right. Okay, so we have period, came out 1, phase shift, came out -1, right? Yeah. Okay, now what does that mean? So when I go to draw my actual graph, where do I start the graph?
-1.
Yeah, at the phase shift, huh? That's your start. So start back here at -1.
What?
Good. Yeah, we'll get to all that. So good so far. Phase shift starts at -1. In fact, let me make that go back a little further. So phase shift starts at -1. And then where do you end? Where does the graph end?
At 0.
Phase shift plus the period. Huh? You have those formulas on your 3x5 card?
Yep.
Want to have those. Then the phase shift is the start, because that's where the graph's been shifted to. So that's where the start will move to. So this one, -1, left 1. And the end is the phase shift, -1, plus the period 1, which is 0. It's going to end at 0. It'll end here, start here, won't it? End at 0, start at -1. At least one cycle will. That's exactly one cycle, right? Because the phase shift is where it starts, and then the period is the width of one cycle. So from where you start, add that, that's one cycle. That's the end of one cycle, isn't it? We good? Now, the amplitude, -3. That means it's going down first, huh? So up here at +3, down at -3. So right in this box, you don't have to do a box, you don't want. I'm going to draw one cycle of the sine. Left edge -1, right edge 0, bottom -3, top +3. Now we know what sine does. Sine starts in the middle, goes high normally first. This one will go low first, and then ends up back at 0. So I'm going to go low to the middle, high to the middle. Does that make sense what I did? I went down to -3 first. We all good with that? Now we got to go look at the multiple choice options, which is often some of the hardest part. Good to there? Okay, now let's go look at the options. In fact, let me just give us a fresh screen of our options and draw the graph right there for us. So what we saw then, one more time on the graph, from, excuse me, from -1 to 0, and up at 3, down at 3, it went, what did it do? It went down and 0, up and 0, didn't it? Okay, so that's what it's doing between -1 and 0. Okay, which one of those graphs does that? Well, I don't know. Could it be A, for example? Look at A. A is back here at negative pi. This is where you want to remember that, I know we think of pi as 180 degrees. That's true when we're talking degrees. But pi is also just a number, 3.14, huh? So this graph is starting back at what? 3.14. That's back at 3.14. It's supposed to be back at negative 1. No way. Everybody see how A's off? A's way off.
That's
Right?
where I thought it was.
Pi's a number. Pi's 3.14. It's supposed to be back at negative 1, not negative 3.14. Remember, pi's a number. And you'll have your regular calculator. You have a scientific. Has everybody got a scientific? Because this is part 2. Part 1, no calculator at all. Part 2, you can use a scientific. No graphing. No graphing calculator today. I brought a couple of my old, in case you forgot today, for part 2. Anyway, so you'll have your regular calculator in part 2. So, pi is 3.14. So that's not right. Okay, let's look at this one. Now, where's this one? Well, this one's back about right. Oops, not working. Right there. Now, what's that? It's supposed to be negative 1. Does that look like negative 1? Maybe. In fact, it is. How do we know? How do we figure that out? Well, let's go on to C and D first. See if we can eliminate those. I should have made that. Yeah, it's got to finish at the origin, doesn't it? Yeah, so no way on C. See how C's up here high at the origin? Remember what the graph's supposed to do again. It's supposed to start at negative 1, go low, go high, and hit back at from negative 1 to 0. It's supposed to hit right back at the origin, isn't it? See how C's hitting high in the middle instead of origin in the middle? So no way C, no way A. So far so good? Because A starts back here at negative 3.14 instead of negative 1. C ends high instead of ending in the middle at 0. Right? So it's either B or D. How do we know which one it is? Well, it's got to be B. Yeah, look back. This one's going high first. That's going high first, yeah. It's got to be this one, which goes low first. It's got to be. There's no E. Notice there's no E. Wasn't that merciful of me? Did you praise my name over the weekend? Like,
No, because I thought maybe
Mr.
it
Heron's so
went off
nice.
and
No, I won't give you E options on the graphs. Everything else I will. So this is like the real test, right? This is the yeah, because I don't want you to get fooled by some little weird thing and go, I thought maybe that graph was off just a little, I want, so I grabbed none of the above because I thought maybe this little, I don't want that to happen to you. So I'm saying, hey, look, on the graph ones, there's no E option. It is one of those graphs. So you know it's one of those. No way it could be D because D goes up first, so he's out. So it's got to be B. Is this right? That they might be more tricky than this sometimes. Is this, which it's supposed to be like negative 1, is it? Yeah. Negative pi over 2, use your calculator, negative 3.14 over 2, that's negative 1.56. Right here is negative 1.56. So it's very reasonable to say that thing a little bit to the right. Yeah, it looks like about negative 1. That looks right. It is right. I know sometimes it's very easy to get confused with all the pi's on the x-axis instead of numbers. But remember, you can convert those to numbers. Pi is a number. It's 3.14. Right? So I just took negative pi over 2, stuck in 3.14, negative 1.56. Which means this point is negative 1.5. So yeah, that makes sense that that's negative 1 right there. Where we're supposed to start, negative 1, right? B's looking good. It's B. All right. Oops, what happened there? There it is. Okay, number 9. So, what is it? Y. I'm just going to fresh screen here. Y equals, number 9, negative 2 cosine 2 pi x plus 3 pi. What was it? 2 pi x plus 3 pi. 2 pi x plus 3 pi. Okay. So, this is the A, this is the B, this is the C. The amplitude is negative. It's going down first, huh? The period, 2 pi over B, 2 pi over 2 pi. Period's 1. The phase shift is negative C over B, negative 3 pi over 2 pi, which is negative 1 pi. The pi's cancel. 3 divided by 2 in your calculator. 3 halves, half of 3, 1.5. Negative 1.5. So we got all that stuff. So let's go to the graph. What does that mean? The graph starts back at negative 1.5. And where does it end? Where does this graph end? Remember where they always end. So it starts at the phase shift. It ends always at the phase shift plus the period, huh? Which is negative 1.5 plus the period is 1, which is negative 0.5. So it's going to end here at negative 0.5, right? Goes from negative 1.5 to negative 0.5, one cycle. We good? What does it do in there? It's cosine. It's a negative cosine. So cosines is going up to 2, down to negative 2. So I'm going to put a box here. Cosines are a U shape. Instead of sine starts in the middle, goes high, goes low, goes back to the middle, huh? But cosine is a U shape. A U shape up for positive cosine, a U shape upside down for negative cosine. This is a negative cosine. So it's a U shape upside down. So it's going to start down here, go high in the middle, come back down here. Like that, huh? Am I going too fast? Is that good? So I found the amplitude, period, and phase shift. It starts at the phase shift, minus 1.5. It ends at the phase shift plus the period. Negative 1.5 plus 1 is negative 0.5. It's upside down, U shape, in that box. Okay, now let's go match it up. That's our favorite part, right? Are we ready? Okay, so let me draw it here for us. What did it do again? Went from negative 1.5 to negative 0.5. And what's upside down? So it was here. Like that, right? Okay, now which of those do that? That's kind of tricky. Might help you. Well, I don't know. It might. Yeah, we got to eliminate some things here. Might help you to do one more cycle. Could you do one more cycle?
Yeah.
How wide? Well, if this one starts at negative $1.50, and this goes up to only negative 50 cents, that's the end of one cycle, right? Went from back $1.50 to negative 50. Where would the next one end?
Plus 0.5.
Plus 50, because it's $1 each time. It's going up by $1. I'm saying money because we think about money numbers all the time. It's easy for us, right? So going from down, you've been in debt? I've been there. I got 5 kids. I live in debt. So down $1.50, up to just being down 50 cents, and then now we're up 50 cents, right? So just going up one jump at a time. So like that. It's going to do. I didn't draw that. It's supposed to hit right in the middle. That wasn't very good drawing. Boom, like that. Is that good? Does that make sense? I think one more cycle would help us see it better. So what did I do? I just did one more cycle, right? I just added. You just take this and you add. You can always just add another period. Added the $1. Why? Because that's the period. Right? Where was it? There it is. Period is 1. Right? So anytime you add the period, you're adding a full cycle. You've done another cycle. So I took minus 1.5, add 1, you're at negative 50 cents. Add 1, you're positive 50 cents. That's another cycle. Each of those is a cycle, huh? So that's a little bit easier to look at. I like it to hit the middle. I like to see what it looks like when it hits the middle. It's just easier on identification. So it has to hit the middle in a U. Well, let's say bye-bye to D and bye-bye to C. He doesn't hit right in the middle at the top like he's supposed to. And he doesn't hit right in the middle at the top like he's supposed to. See how it's supposed to hit right at the top in the middle? I'm talking about this point right here. Look where he hits the middle. Right there. Look where he hits the middle. Neither one of those is good. This one's good. He's hitting the top in the middle and he's hitting the top in the middle. So far A and B are still in the running. Do you see that? Y'all tracking with me? So how do we know if it's A or B? Well, we got to see how far back. How far back is it supposed to be? This is supposed to be back 50 cents, right? 0.5. Where is it? Pi over 2. Negative pi over 2. What's that? Pi is a number. Negative 3.14 over 2. Negative 1.56. No way. Not even close to negative 50 cents. Do you all see that? See where this point is? The left of the U, this point here is supposed to be negative 0.5. This is right because it's way closer. This right here, negative pi over 2, is negative 1.56. This is much closer. Yeah, that looks right. It's A. Are we good there? See how I discern? Now let me slow down there for a minute. Let you digest that. Do you see how I'm changing those pi numbers? So yeah, maybe it would help you. Yeah, let me help. I bet I could do this better. Way that's more understandable.
So
Just change all the pi numbers.
convert all the pies.
Just cover all the pi. So pi, what is pi? This is 3.14 right here.
I can't add that to my screen.
This is negative 1.56, half a pi. 5.57, whatever. Just say negative 1.5, close enough. Just say negative 3. Just say, hey, pi is 3. That's good enough. Pi is 3, right? It's 3.14, and it goes on and on from there, but whatever. Just say 3. So negative pi is negative 3. That's about negative 3. And what's half of 3? Half of $3. $1.50. That's about negative 1.5. This is positive 1.5. This is positive 3. Right there, right there, right there, and right there. So just do that. Would that help you? And this is negative 1.5. This is positive 1.5. This is, oops, not positive, but negative 3, positive 3. And here, 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 and here. Is that good? So now, where's it supposed to hit? Well, it's supposed to, I kind of erase some stuff here. There. It's supposed to be back at negative 0.5 for its first loop. This is negative 1.5. No way. This one, yeah, that looks better because this all the way to here is negative 1.5. So that looks right, doesn't it? You all see that? Is that helping any better? No? I'm not seeing many happy looks. Many happy returns. No, I'm not seeing it.
I got it.
Okay, you guys good with that? Is there more I can say? Right? Pi over 2 is 1.5, right? It's half of 3. So that's back 1.5. It's supposed to only be back half, 0.5. Not 1.5. So it's not B. Is it A? Yeah, that's much. It's the only one left. The other one's hit wrong in the middle. So what I did is I found that extra middle piece, didn't I? All right, I better move on. So that number. Okay, so number 10. Let me rewrite it here. 3 cosine 3 pi x. Yeah. Okay. Let's take a look. So all the same stuff again. Amplitude, period, phase shift. A, B, C. So we got A, B. The C here is 0 because there's nothing added in the parentheses. It's 0. C is 0. So the amplitude is 3. The period is 2 pi over B. 2 pi over 3 pi, boom, 2/3. So the period is 2/3. What's the phase shift? Negative C over B. Negative C over B. So negative C, which is 0 over who cares? 0 on the top of a fraction means that's 0. Doesn't matter what B is. You can put in B if you want to. 3 pi, whatever. 0 over 3 pi is 0. 0 and negative 0 is just 0. No such thing as negative 0.
So we don't simplify the period.
What's that?
We don't simplify the period like in decimal.
I did simplify the period. I canceled the pi's.
But like to a decimal.
If you want to.
Okay.
Yeah, it's your choice. Yeah, you can do that if you want to. Yeah, make it 0.67 or whatever you want. Yeah, you could do that. Okay, so where does this graph start? Where does she start?
0.
0, the phase shift. Where does the graph end? The phase shift plus the period. What's the phase shift? 0.67 or 2/3 plus the period 0. That's going to end at 0.67, isn't it? That might be a good idea. on that to do that Ariana was saying about changing it to decimal. That might be helpful. So, all right, so now we got where it starts and ends. Let's go. So we start at 0. We end at 0.67. It's a cosine graph, and it's a positive cosine. So it's going to start high, go low in between, come back high. Between 0 and 0.67. We good? Let's go track it down. So we go from 0 to 0.67, start high, go low, come back high. All right, which one's doing that? So it's got to start high. Let's start eliminating things right now. It's got to start high. Who starts high? He starts at 0. Bye-bye A. He starts at 0. Bye-bye B. He's 0 in the middle. I'm looking at where they are in the middle. It's supposed to be at its high point, which is what? 3. It's supposed to be up at 3. He's up at 3. Okay, he's maybe. And he's up at 3. So it's either C or D. So far, so good? It's either C or D. Because A starts in the... He's at the origin in the middle. And so is B. They're not supposed to be at the origin. They're supposed to be up here at their high point. It's a cosine graph. So, is it C or is it D? We got to do our thing with pi. Got to do our thing with pi. So, our graph is supposed to finish his first. Here's one cycle, boom, and here's one cycle, boom. Didn't draw that very neatly. Supposed to finish one cycle at what? At 0.67. So figure out what these pi's are. This one goes past pi over 2. This one's going past 1.5. No way. You with me? It's supposed to stop at 0.67. 67 cents. Not even supposed to make it to $1. This one's already past $1.50. He's still going. Pi over 2, right? That's 3 over 2, half of $3, $1.50. He's already passed. He's more than $1.50. He's not stopping at 0.67. No way. C, you're out. D must be the answer. Good? Feeling better about identifying those graphs? Just change those pi numbers. Pi's 3. Good enough. 3. Half a pi is $1.50. Good? Feel like you can do that on today's test? For the big hand. Why? It's right here. Got it now. Don't let it go. 13?
Still get the answers what they mean. Because, like, you know how, like, for A example, A is such a straight line going down, it's going to be a whole number. And we take something like B, you know it's going to, well, amplitude, by the way, amplitude is a whole number. Then for B, since it's kind of curvy, it'll also be in a fraction form. But you know how it's, like, curving right there at the x-axis? Does it mean anything if it curves, like higher than that or lower than that? Like, does that mean anything? Or?
Like, what do you mean curves higher or lower?
Because you see, like, on the x-axis, how it slightly starts to, for B, how it slightly starts to go right, like, towards, right when it's the x-axis.
Gotcha.
But, like, I've seen, like, some graphs, maybe it was just gibberish on purpose, but, like, let's say it's high on the, like, close to the y.
Oh, the curving is higher.
That would where the D comes in, right?
Yeah, that might be the D.
There's a vertical shift in it.
Yeah, it's hard to do much with that. You're not going to be expected to you don't have to pay close attention to that. Yeah, let me just I'm sure there are bigger things we could say, but for now, don't worry about it. Don't worry about that a lot. All right, so let's identify the A, B, and C. So the A is 3, the B is pi over 2, the C, again, is 0. All right, so the amplitude is 3. The period is 2 pi over B. 2 pi over B. B is pi over 2. Are you okay with, how do you handle 2 pi over 2? What do? Give it a flip. Grab that, flip it up. So it becomes 2 pi times 2 over pi, right? Right, the one on the bottom, division is upside down, multiplying, flip it up. And then these pi's cancel. 2 times 2 is 4. So the period is 4. The amplitude is 3. The period is 4. What's the phase shift? It's negative C over B. And the C is 0. So negative 0 over B over pi over 2. That's just 0. 0 in the top fraction is just 0. Negative 0 is just 0. All right, so we got our phase shift and our period. The phase shift is where it starts. Where does it end? It ends at the phase shift plus the period. We've done a lot of these now. You can do these in your sleep now, right? Maybe not. Period, phase shift, so 0 plus 4, 4. Yeah, dreams of math. Okay, starts at 0, ends at 4. Starts at 0, ends at 4. We good? Starts at 0, ends at 4. Right, everybody good with that? I found the phase shift is 0. And then the ending is phase shift, 0 plus period, 4. 4. All right, so what does that mean? So let's oh, what am I doing? This is craziness. I'm just losing my brain. You guys got to tell me when I'm being crazy. You don't do any of this for a cotangent graph. This is what we do for sine and cosine. This isn't sine or cosine. Maybe it's helpful I did that. Garbage. So, right? All of that amplitude, period, phase shift, all that, that's for sine or cosine. I was just testing you. No, I was messing up. But maybe it's helpful that you won't say it. So today, on today's exam, if you see sine or cosine, yeah, that's when you do all that amplitude, period, phase shift, start and end, all that stuff. But for the other 4 graphs, tangent, cotangent, secant, cosecant, we don't do that. Well, what do we do? Well, we have them on our 3x5 card. I hope you do. Let me do them again real quick. What does tangent look like? They all have the vertical. All 4 of those have vertical dotted lines, the vertical asymptote lines that contain a cycle. So tangent goes from negative pi over 2 to positive pi over 2. What does he do in the middle? Snake going up to the right. That's tangent. And then cotangent, over here, cotan, he'll go from 0 to pi, or 180, and he's a snake going down to the right. Because he's upside down of tangent. He goes down to the right instead of up to the right. Between 0 and pi, his 2 dotted lines, his 2 vertical aspect lines are 0 to pi, tangent's negative pi over 2 to pi over 2. Remember, that's how we handle those 4. Sine and cosine, we do all that amplitude, period, phase shift stuff, ABC. But tan, cotan, we just have the basic graph on our 3x5 card. Now let me come down here and also do the other 2. Secant. Remember what secant looks like? He follows the same 2 vertical lines as tangent, meaning negative pi over 2 to pi over 2. And in the middle, he's a what? A U at 1 going up. At 1 going up. And then he has another part going down, and he goes on and on. And then over here we have cosecant, which is the same as cotangent. The cos go together. And he's also going to be a U shape. Whoop, he's going up between 0 and pi, and then he has another part going down, and on he goes.
Those already start at 1 plus 1 minus 1, right?
Yes. Well said, Jose. Plus 1, minus 1. Yeah. And right, this one's at minus 1.
Unless there's a number in front of it already.
Or if there's a number in front of it, like 3, then it's plus 3 and minus 3. Totally. Very good. Yeah, so everybody getting the big idea. You can get messed up like I just did. You just get in that amplitude, period, phase shift rhythm. I did it so many times. But also when I got into tangent, I tried to do the same thing. No. Right? If we do any, so sine and cosine, we do that whole amplitude, period, phase shift, start and end stuff. But for tan, cotan, secant, and cosecant, the other 4 graphs, we just have these 4 on your card. And it's all about the 2 vertical lines. You take the inside and you put it between the 2 vertical lines with the double inequality and you solve, which I'll now do. Right? That's how you handle these 4. So let's go back and do it right this time. Okay. So I grab the inside, what's being plugged into the toaster, into the cotan function. And I say inside for cotan, you're between 0 and pi. So inside, which is pi over 2x, you're between 0 and pi. Is that good so far? Why 0 and pi? Because that's for cotan, right? His two vertical lines are at 0 and pi. Same here, 0 and pi for cotan. So I say, all right, inside, middle, you're between. I want to find the graph, the middle of the graph, the inside, whatever they're plugging is between 0 and pi. You do that for all 4 of these. And now you just need to solve for x. We want x alone. X is saying what he's always saying. I want to be alone. Get rid of this pi over 2 thing that's next to me so I can be alone. So what do we do to get rid of that pi over 2?
Multiply 2 over 5.
Well, yeah, multiply by the upside down. Whoops. 2 over pi. That good? And whatever you do to one part, do to all 3, huh? And that'll cancel the 2's, cancel the pi's. X is alone in the middle. Over here, 0 times anything is 0. Over here, pi over 1, the pi's cancel, it's 2. We good? So between 0 and 2. So that means this graph is going to do its thing. Its cotangent upside down snake thing. Right here. Between 0 and 2, that's where you have the verticals. And what it'll do, a snake going down to the right, at least one branch, and it just repeats it forever, right and left. A snake going down to the right between 0 and 2. We good on that? Now, could A be the answer?
No.
Why not? What's immediately obviously wrong with A?
It's going the wrong way and
Snakes-
the cross is in the middle.
Snakes are going up. No, our snakes are going down. Now B, the snakes are going down, so that might be the answer. Let's go. Okay, so now you got to go to the next page. So B's still running. Could it be C?
Yeah.
Snakes are going down, looks good. D, could it be D?
No.
No, D's out. Snakes are going up to the right. So we're down to 2 options. There is no none of the above. There's no E. So it's down to either B or C, and they are stinking close, aren't they?
Yeah.
Too close. I wouldn't think this is a fair question on an actual test. B and C are super, super close. I mean, it's hard to even tell them apart at all. I mean, they're both going down. They're both going down to the right. They're both really, 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 really close. Anybody see a good way to tell them apart?
Yeah. The amplitude of 3 is a whole number, so it's going to be a straight line.
The amplitude of 3 is a whole number. So it's more straight line?
Yeah.
Let's see. So you're saying B is more straight line than C? C is more curvy?
No, I think C is like more straight line.
C is more straight? Yeah, I don't think that's a good way to... I think that's going to work. I can't tell which one's straighter. Benjamin, do you have an idea?
That's kind of what I was looking at, because you can see the curvature changes and starts going the other way. On B, it changes at 1. And on C, you can kind of see it changes at 3.
B, it looks like it hits the y-axis.
So Benjamin, you're saying right here's the beginning of curvature change?
Yeah, it starts going the other way.
About 1. Yeah, it's technically curving the whole way, though. I mean, right? Even it curves more dramatically at 1, but it's always curving. I mean, right? It's always coming in. It's always going to the right. You know? It's a little shaky. I wouldn't bet my life on that.
Yeah.
Right? I mean, it's curving the whole way on that, right? It's somewhat straight, somewhat curving the whole way. B and C, both. Super, super close. Isn't the answer B?
No.
C.
Is it C?
Because B is hitting 0. Okay.
B doesn't quite hit 0. See, it just gets really close.
Looks like it hits it. That's how I determined that.
I determined it because C was more stretched out.
It had more space between the asymptote line and...
Yeah. Anyway, I'm going to leave it. That's just too close. Those are really, really, really close. Yeah, if it actually crossed it, you know, I would be fair game for that, but it doesn't really touch it. I mean...
If you zoomed in...
Yeah, if you zoomed in like crazy, would there be a gap or not? Right.
Is it making the x-axis at the same location on both graphs?
Not quite, but so close that it's hard to tell. You can tell it's different because see how this one runs over the pi over 2? That's what I noticed. And this one doesn't quite run over the pi over 2?
Yeah.
So they're different, but they are so stinking close. They're just too close. I don't think that's a good question. Too close. I got to move on. All right. So 14 was, okay, so same thing. You grab the inside. You say inside. You've got to be between, what is the bounds for cosecant?
0 and pi.
Yeah, if you go back, cosecant is just like cotangent. 0 and pi are where his vertical lines are, and the graph is inside. The U shape is inside of those two, huh? So we say, all right, between 0 and pi, so that means x plus pi over 4 is between 0 and pi. So how are we going to solve? X is saying what he's always saying, I want to be alone. So what do we do to get x alone? Subtract pi over 4, subtract pi over 4, subtract pi over 4. The left side's easy, minus pi over 4. What about the right side? Well, put this over 1. To add, subtract, you need common denominator, huh?
I like your whole pi thing.
Oh, a whole pi, take away a quarter of a pi, leaves 3/4 of a pi. Yeah, does that work for you?
It's a little more
Yeah,
visual.
that says 1 whole pi, take away 1/4 of a pi, leaves 3/4 of a pi. But if you want, you can multiply top and bottom by 4. And you get 4 pi minus 1 pi is 3 pi over 4. Is that good like that? Now, so that means it's going to have vertical lines between negative 1 pi over 4 and positive 3 pi over 4. So I'm looking, now where are the vertical lines? Well, like they're not showing the vertical lines, but we can tell where they are because of where the graphs go up or down forever. That's what graphs do at a vertical asymptote line, is go up forever or down forever. So this one looks like it's past negative pi, isn't it? The real graph, so I'm kind of running out of room here. I can put it up here. The real graph is supposed to go between negative pi over 4, which should be about right here, and positive 3 pi over 4, which is right here. Everybody see that? How did I come up with that? Well, negative pi over 4 is that's 1/4 of a pi. This is negative pi. This is half a pi, and half a half is 1/4 of a pi. Huh. On that. Yeah.
Wouldn't it be going down though, since it's like -3 is the amplitude?
Oh yeah, thanks. I didn't notice that. You're right, Ani. Totally right. Down at -3 even. Going down, exactly right. Everybody okay with how I found the place though, the negative pi over 4 on the graph, right? Because this is pi here. This is from there to there is pi. That's a whole pi. So this is half a pi, so this is a quarter of a pi, isn't it? Everybody good with that? Quarter of a pi? Oh yeah, A's looking better now, isn't it?
What's the opposite?
Yeah.
Yeah, because I was getting all mixed up. I forgot about the negative thing that Ani pointed out. Yeah, so this looks sort of right about here. Negative pi over 4 going down like that. That's looking good, isn't it? 3 pi over 4 right here. Yeah, it's looking good. I forgot about that. That's tricky. I forgot about that negative part. So, okay, could it be B? Let's look at A's looking good. Let me make sure by checking out B, C, and D. There is no E. If I can eliminate B, C, and D, I'm confident in A. I'm already pretty confident in A. It looks good. Could it be B?
No,
Why not?
because it's going up.
It's going up. We got a branch that hits the middle going down, not up. No way on B. No way. Okay. Could it be C?
No, it's going up.
Yeah, it's going up in the middle. Now D's going down in the middle, but not like that. It's supposed to hit with the left edge, not the right edge. Right? See how this one hits with the left edge? It's more shifted to the right. So it's A for sure. Everybody see that? That was a hard one, actually. How are we doing? You okay with these graphs?
I had a question.
Yeah, Jose.
Okay, well, where it's, x plus pi over 4.
Right.
To get x by itself, you subtracted pi over 4.
Right.
On the previous problem, it was pi over 2x, and you multiplied it.
Yeah.
What's the difference?
Great question. Look at the pi over 2 and the x. What's in the middle of the? I'm sure Jose's not alone. That question's a good one. What's in the middle of this last 13? What's in the middle of the original? Nothing, which means they're times. So you can't get rid of times by adding or subtracting. You got to multiply the opposite, which is called dividing. Right? Does it make sense? Whenever we get x alone, we always get x alone by doing the opposite of whatever's there. So the opposite of multiplied by pi over 2 is multiplied by the upside down. Whereas on number 14, we had something added.
Yeah.
So the opposite subtraction. Yeah, really good question. Good. All right, those are tricky, huh? You okay with the graph thing? See how I honed in on the, again, this is a whole pi, half a pi, quarter pi. And like Ani reminded me, it's going down because of the -3. So normally the U-shape's up at 1, which I did draw it at first, but it's down at -3 in the middle between -1/4 pi and +3/4 of a pi. Gotta be A.
Since cosecant and sine are cofunctions, can I just graph sine, replace cosecant with sine, graph it, and then do the inverse? Would that find it?
Yeah, but that's really hard to. I mean, that would.
That's how I've been doing it.
Yeah, that'll work if you just graph sine and then do the
Inverse of
and then you flip them. You know how to do that? Like at the top of the U's, it goes up, and yeah, that'll work.
So,
Yeah.
So, okay, so secant would be going up, correct?
You mean this is cosecant? You asked about this
So
one?
secant would be going up.
Normally, but because there's a -3 in the front, it's going down.
So it doesn't matter if it's cosecant though. Cosecant will go down automatically, wouldn't it? Whether
No,
it's negative or
no. There they are. So there's the original. See, they're going up.
Oh, both of them go up.
Both go up. Both cosecant and secant go up. Yeah, you want to have those in your 3x5 card. You're making up new ones for your card there, Jose? Once they go down.
It just determines
Hey.
where
So
they.
then what does it do if it's negative and tan or cosine?
Flips the graph upside down.
But isn't that already like doing it if
Instead of so tan goes up to the right naturally. Cotan goes down to the right naturally. So a negative cotan will look like a tan and flip to go back up.
Okay.
Does that make sense? And a negative tan will look like a cotan. Just flips it upside down. Yeah. All right. We've talked a lot about graphs. You guys have learned a lot about trigonometry graphs. All right. Good. Okay. That's a good one. So number 16. Okay, solve the triangle. So, all right. So little a is 1.5 over there, and big B is 40. I don't have room to write this stuff. Here, let me just squeeze it. Little a is 1.5. Little b, or big B, is 40.9 degrees. Find little c. So they want me to find this side. So remember SOHCAHTOA, right? SOHCAHTOA. So what trig relationship involves this angle, this side, and that side? This is opposite, adjacent, hypotenuse, right? Yeah, does everybody see that? This is the side next to the big B, 40.9 angle, right? It's adjacent to it. This is the side. The bottom is opposite of it. And of course, the C is always the hypotenuse. So if they want me to find C, which is what they want me to find, then that's adjacent over hypotenuse. That's cosine. So cosine of 40.9 degrees is adjacent over hypotenuse. So it's 1.5 over C. Okay, and so how do we solve when we have a fraction with an equation? Yeah, put it over 1, diagonal, cross multiply. C times cosine 40.9 degrees is 1 times 1.5. So C cosine 40.9 degrees is 1.5. Last step to get C alone, divide by cosine 40.9 degrees. Boom. Nope, didn't need to. You could have, there's another way, you could have found this angle down here, then you would have done sine. But not needed, I just used the one they gave me, just did cosine. It'll work either way.
Could you use cosecant? Cosecant of 40.9?
Okay, what would cosecant of 40.9 be?
Hypotenuse over adjacent.
Hypotenuse over opposite. Remember, it's upside down as sine.
Okay.
Okay, so we don't want to do cosecant, because that'd be hypotenuse over opposite, and we don't know the opposite on that. So I just used cosine because I just wanted adjacent and hypotenuse.
Or even secant.
Yeah, secant. You're right. Secant would have worked, because that's opposite of cosine.
That would work?
That would, but you don't have a secant button on your calculator.
Could you do 1 over?
You could, but I mean, at this point, is this really making it easier?
Oh, okay.
You know. So, and then we just divide those two, and we get the answer in our calculator. Hopefully. Or maybe, is it none of the above? And you got to make sure, what mode are you in there? Degree. I got this bad calculator here. 1.98, is that what it is? So C is 1.98, none of the above, disturbing. All right, but not to you who have great confidence in your trigonometric skills, right? All right, so that's 16, 17, they give you A is 17.1, so this one's over, and I'll come up here. Little c is 26.8, and they want me to find angle B there. So SOHCAHTOA. What trig relationship involves this angle and these two sides? It's again cosine again, right? So we say cosine. No, not coup. Cosine of B. I don't even know what B is. It's adjacent 17.1 over hypotenuse 26.8. Adjacent over hypotenuse. Good so far. Adjacent over hypotenuse. Okay, so how do we solve for the B there? Inverse cosine inverse. Yeah, because that's what gets rid of a cosine, huh? Is inverse function gets rid of a regular function. So then B is inverse cosine 17.1 over 26.8. So you just do that in your calculator. 17.1 divided by 26.8. And then you got to hit inverse cosine. I'm getting 50.35 degrees. 50.4. There it is. C. Good on that one. And one more, number 20. I'm printing a math problem. All right, so building 230 feet tall, casts 30-foot shadow. Person stands at the end of the shadow and looks up to the top of the building. What is the angle of the person's eyes to the top of the building? Judge hundredths of the degree. Assume the person's eyes are 6 feet above the ground, above ground level. Okay, so yeah, so basically we've got this. So the person is standing maybe here. Oops, it's supposed to be their eyeball right there. There's their eyeball. They got a big head, kind of short legs. So there they are. They got a big eye. And that eyeball is looking up at the top of the building. The building is 230-foot tall building. Casts a 30-foot shadow. So that means all this is 30 feet, right? A building 230 feet tall casts a 30-foot long shadow. If a person stands at the end of the shadow and looks up to the top of the building, what is the angle of the person's eyes to the top of the building? Assume the person's eyes are 6 feet above ground level. 6 feet above, that's tricky, huh?
I took the 230 and I subtracted 6 feet from it, and then solved it from there.
That's a good idea. A person stands at the end of the shadow. A building 200 feet tall casts a 30-foot long shadow. If a person stands at the end of the shadow. Oh, so I don't. You know what? What's wrong with my my diagrams?
Your person's too close. He's gotta
My
go-
person's not at the end of the shadow.
He's gotta go to the end of the shadow.
I blew it with my person. They're supposed to be at the end. I thought something was wrong here. What is it? So here they are with their eyeball. Whoops.
No, you're standing up.
It says standing up, yeah.
Yeah, that's standing up. Don't you tell my
Okay.
my drawing.
But it's not
My
too-
drawing is the problem now.
The person's eyes are 6 feet above ground level.
Right, I understand. So, so I just can't draw. It's my problem. There's the person standing up. Here, let me do this. Person's,
Like a 6 feet
yeah. So this right here, this person's 6 feet. The building's 230, right? So all of this is 230. But if you just go from here to here, this is the trick that Pauline's mentioned. If you just go from there to there, it's going to be 230 minus 6, which is 224. Y'all see that? Because this is 6. Person 6 from their eyes are 6 feet above ground. You see that? Although that's 6 feet, it looks big. It's as big as a 230. But do you get the idea? Does that make sense? Is that confusing? Person standing at the end of the shadow. Their eyes look up to the top of the building. The building's 230 top to bottom, but from their eye level up, that's the triangle we want. Eye level up, it's 224. Right? That's the triangle. This is 230 down here, but this is also 230 here. They're the same. That width. Oh, sorry. 30. Which looks bigger than the 230 the way I've drawn it.
I know, you did the same thing.
Anyway, my drawing leaves a lot to be desired, but I hope it's making sense for you. So it's 30 wide, 224. So that's what we got to do with the 6 foot. 224 is the height over there, isn't it? Right? Because he's 6 foot tall, so from eye level to the top of the building, subtract them 224. So we got to find this angle theta. That's the angle to the top of the building. What trig, we're thinking SOHCAHTOA. What trig relationship? Yeah, this is opposite, adjacent, hypotenuse. We have opposite, adjacent, tangent. Tangent of that angle, theta, is opposite, 224 over adjacent, 30. Opposite over adjacent. So tangent theta is 224 over 30. I want to get theta. How do I get theta? I'm going to take tangent inverse. And it cancels out. Theta is tangent inverse of 224 over 30. So 224 divided by 30 equals tan inverse. I'm getting theta as 82.4 degrees. Is it not there? Oh, 37, yeah. 37, it is there. 82.37 degrees. See?
Yeah, if you don't subtract the 6 first, you get 82.57, I believe.
Ooh, and they put it there too. Publishers make these tests, and they're trying to sucker you in. Yeah. All right. Was that fun? That was over an hour.